This week on the Tech on Tap podcast, we talk about medical imaging in the cloud with AWS FSxN.
Welcome to the Tech on Tap podcast with Justin Parisi.
I love NetApp.
Oh, yeah.
NetApp. I love this company. Support.
I love NetApp because it's so funny.
Hello and welcome to the Tech on Tap podcast. My name is Justin Parisi. I'm here in the basement of my house, and with me today I have a couple of special guests to talk to us all about medical imaging, specifically with Amazon FSxN. So to do that today, we have Kim Garriott. So Kim, what do you do and how do I reach you?
I am the General Manager for Global Healthcare and Life Sciences at NetApp, and I have spent over 25 years of my career helping organizations understand how to best design clinical workflow and data management strategy around medical imaging and other critical clinical data in our healthcare enterprises.
Awesome. Also with us today, we have Sasha Pagel from AWS. So Sasha, what do you do over there at Amazon and how do we reach you?
I work in what's called the Worldwide Specialty Organization, or WSO. I am directly aligned with our storage services. I am focused on healthcare and life sciences workloads, specifically medical imaging and R&D workloads like genomics, and really helping customers be able to choose the right collection of storage services along with compute to enable their workloads in the cloud.
All right, excellent. So we're here to talk about medical imaging, and we're going to talk about it in context of Amazon FSxN. So to do that, we want to first talk about what medical imaging actually is, what it means, and what sort of things are involved in it. So Kim, give me your overview of medical imaging.
Yeah. So medical imaging, as we think about it today, is really different than we maybe thought about it 20, 30 years ago. Today, when we talk about medical enterprise imaging, it really is looking at all of the different medical images that are acquired across a healthcare enterprise. Historically, we think of that as being radiology exams, CTs, MRIs, X-rays, cardiology exams like echoes and EKGs. But then there's also a whole world of other imaging when you think about digital photography documentation of post-op wounds or surface anatomy for lesions on the skin that a dermatologist may track. And now we also see what I like to think of as the final analog imaging workload that we have in healthcare, which is pathology. So we're now starting to see lots of interest and movement into digitizing the glass pathology slides and now presenting those as digital content for the pathologist to interpret visually through the computer. And the reason that I've been passionate about medical imaging really for my entire career and why we have a big focus on medical imaging at NetApp is because of all the data in the world. When you look at the global data sphere, we know that healthcare data comprises approximately 30% of the entire global data sphere. When we look at healthcare data, we know that 80 to 90% of all healthcare data is comprised of medical imaging. So when we think about the data that's generated in a hospital, medical imaging is big data. So we're really excited to work to develop solutions that are going to serve healthcare organizations and customers in the best ways possible in learning how to manage these really large-scale data implementations and deployments.
It's pretty impressive to see what a particular organization in a year might generate a petabyte's worth of digital pathology images. So definitely data is getting bigger. It's getting bigger by different imaging modalities, and there's overall just much more of it.
With any sort of large data set, there's always going to be a subset of challenges. So what are the specific challenges that are unique to a medical imaging workload that you might experience when you're trying to store it either on-prem or in the cloud?
Yeah, so number one is really scale. How do you keep up with the capacity to be able to scale quickly enough to be able to have the storage to hold those images or retain those images? And we talked a little bit about digital pathology. And Sasha just made a quick reference that an organization could easily be generating a petabyte of data a year just from the adoption of a digital pathology workflow. When we look at what we've historically seen with medical imaging, we're more in the terabytes per year generation. And even for smaller organizations, it may be low number of terabytes. But digital pathology and this evolution that we're seeing in the field of pathology is going to have a 10 times multiplier on that data. So organizations and CIOs, as they're thinking about their long-term IT strategies, are really focusing in on how do I most effectively scale to meet the growing demand and the growing capacity of the medical imaging data. Along with that, the equipment vendors are always improving the technology. If you look back to the late 80s when we first introduced MRI technology, we may have only had a handful of images that makes up that study. Well, now you fast forward and we can have thousands of images that make up a single exam that you may have or MRI that you've had taken as a patient. So the technology is increasing the capacity and the volume of data being generated as well. So these things are very top of mind for organizations as to how they're going to manage the data. Couple with that, a need to really achieve operational efficiencies. We're still recovering from the pandemic in healthcare, as most industries are, but very much so our hospitals and health systems were hit very hard. And we're still operating in negative margins in 60% of the healthcare organizations across the United States. So we're looking to understand how we can manage these ever increasing volumes of data in the most cost-effective ways, and then layer on cybersecurity and the concerns around data protection, which those threats only become more rapid and increasing every day. So how do we really protect the data in the best ways to ensure patient privacy and non-disruption to our clinical operations in the case of something like a ransomware attack? So I think there are many things that we take into consideration and that customers are challenged with, but those would be the very top things, right? Managing scale, achieving operational cost efficiencies, and ensuring the highest levels of cybersecurity around the data. Sasha, what did I miss?
I think the one thing that I would add is also just thinking it from the experience and staff dimension, right? Because all these areas that you just mentioned, scale, being actually knowledgeable about your imaging ISV, where they're going with their modalities, operational efficiency, doing cost optimization. Today, someone that's responsible for ensuring that images can be delivered to the radiology business, covering all those challenges is really hard, especially if you have a really lean staff, right? I guess the challenge here is ensuring that you have a staff that can really take advantage of their skill set and be able to apply that and solve those challenges that you just pointed out.
Yeah, that's a great add. Really important.
Okay, so that's the challenges. Now let's talk about the solutions. So how do we solve these problems? What are some things that we need to do or consider when we're storing medical images in enterprise storage?
Oftentimes what we've heard when we've gone and spoke to customers and listening and hearing hints from them is a lot of the items come back to cost optimization and operational efficiency. And so if you're talking to the lead IT director, the things that we may actually hear is, what can you do to help us become more agile in our operations? Is there a better way to manage this second copy of images that we have in our DR data center? Basically, they're saying, can we store that copy of images in the cloud? Because if that's possible, then that also introduces opportunities for cost optimization relative to what's going on-prem, and ultimately taking advantage of some optimizations by moving some of those images into the cloud, which then also prompts the discussion, well, how would you do that? Because there's lots of choices.
And customers still, in a large part, are more risk averse than others. Some are more aggressive than others. But generally speaking, there's still a lot of cloud curiosity out there. So how do customers begin to think about other avenues for the management of this data that could be more cost effective or could help with staffing constraints or knowledge constraints that they have in that staffing, or simply gaining the compute power that's needed if they want to leverage medical images for AI development or advanced analytics? So we're starting to help organizations think creatively about how they best address those needs in ways that are less taxing on their current on-prem data center infrastructure. And many customers are also asking, hey, I want to be able to reduce our data center footprint how can you help me do that? And to answer that call, we have developed a solution together for medical imaging on FSx for NetApp ONTAP. And that allows customers to have a great latitude of possibilities on how to manage their imaging data, whether, like Sasha said, it is for secondary copies or tertiary air gap copies for the highest degrees of cyber resilience, or it's moving backup copies to the cloud. We know that as we move into these petabyte scale workloads, restoring petabyte scale backups becomes very, very difficult using on-prem technologies. And research shows us that a very high percentage, 60% or plus of these petabyte scale backups actually fail on restoration. So with this, we're able to offer customers a variety of ways to be able to manage their mounting challenges around medical imaging workloads, while also looking to be able to gain those cost efficiencies at the same time.
So we've focused on topics or concepts about disaster recovery, backups, data protection, cost optimization. On the flip side, we need to think about what are the possibilities for innovation. So you could be, for example, motivated to move to the cloud because there's a secondary use and value to those medical images that you have. One of the other motivators to move imaging to the cloud is you potentially can unlock additional value from that cohort of images that you have. That may not apply to every type of healthcare provider, but if there is a subset of healthcare providers out there that are on the cutting edge and developing new ways to detect features in a particular image. And ultimately that leads to more efficient potential workflows for radiologists longer term, for example. There's a whole bunch of other innovation that can actually start to happen when you have access to those medical images in the cloud.
Yep, absolutely. And I think we're going to get a lot more traction in that area. We're going to see customers acting in ways to really leverage their data. We've talked about for years why we don't delete medical images. As well, storage is cheap. Well, storage is getting large, right? And while it may be not expensive to buy a terabyte of storage, when you multiply that and multiply that and multiply that over years, and you take in the environmentals that are being consumed in all these data centers around the world, in each hospital, if they have their own data center, that's a lot of environmental consumption. Now we're starting to think about, okay, there is a cost to retaining all of this data. We've kept all of this data for years. And the reason that we've kept it, other than that storage has been cheap, is because we want to leverage it in research. We know that there's great value in this data, and we're really starting to see organizations harness the power of their imaging data in different and new ways. And of course, AI is helping to drive that. And whether an organization wants to contribute anonymized, de-identified imaging data in a way that can be used to train AI models, or they simply want to run advanced analytics where they are not lending the data into the development of an AI model, but really just doing analysis that will aid their own research, being able to promote cohorts of data into a cloud instance gives an organization the flexibility to be able to unlock the power of the data without having to spend large amounts of money to buy the resources to have those capabilities on-prem in the existing environments today.
I just thought of one additional reason why we'd be moving medical imaging workloads to the cloud. We've seen medical imaging ISVs also taking a sincere interest in making moves to take their imaging solutions and bring them to the cloud, and coming up with new ways to offer their imaging solutions to customers. And as a consequence, that also opens up new possibilities of how end users would be able to access and do their work from potentially different locations. And really that's introducing potentially some new agility for an organization to get their work done.
Well, I think it's going to be a game changer when it comes to being able to get the right images to the right clinician at the right time, especially when we think about how images are interpreted in emergent cases that may present to an emergency room overnight. And still, most hospitals unless you're a very large academic medical system, you likely don't have radiologists on staff at night in the wee morning hours. And you partner with other organizations to do those preliminary reads or maybe even do final reads overnight. And it's always been really challenging in that scenario, or in the scenario of I've acquired a new hospital into my healthcare system and now my radiology practice needs to read those images, but my systems aren't necessarily integrated yet. Using cloud technology and thinking about the latitude that we have, we can now think about ways of making information more universally available to all of the clinicians that have access to it. And instead of physically having to move data from site to site, we can now have our clinicians tap into more of a federated pool of data that resides in the cloud for that particular organization. I'm certainly not talking about mixing data from different healthcare organizations, but the information can be made centrally available to a wider number of users in a way that we've not been able to do in the past without literally digitally sending those images to another facility.
So that's the medical imaging side of things. Let's talk about the Amazon FSxN side of things. So let's start with, what is Amazon FSx, and specifically FSxN? I know the answer, but I'd like for you to tell me.
So first off, we can start with the official name. It's Amazon FSx for NetApp. If you're working with someone from AWS, you may often hear FSxN. That's our shorthand way to refer to it. Or you might also hear it referred to as FSx for ONTAP. And the reason why I kind of land on the word ONTAP is really, together with NetApp, AWS have been in a key strategic partnership. Really, I think it might be actually 14 years now since the first steps into the cloud. Really being able to bring the ONTAP technology, all the key enterprise capabilities and features that are available with the ONTAP solution, and really delivering that as a managed service through FSx on Amazon. And when I say managed service, that means as AWS are taking out a lot of the heavy lifting in terms of being able to maintain and operate a file system like ONTAP on AWS, so that an IT operator doesn't really have to think about those things like, oh, I got to call up support, got to change out disks, have to update the actual OS for the file system and do all sorts of updates. All that's taken off the table. And really, it's about maximizing the key capabilities of ONTAP on AWS and to be able to manage your data as if you were managing it on-prem, but without those day-to-day lower level management challenges.
Yeah, and I think that we've had a lot of success with our imaging software partners that are choosing to build their next generation managed service, software as a service models on FSxN, because their administrators and their customers' administrators know and love that traditional on-prem ONTAP environment, that look and feel of ONTAP. And now moving to FSxN, it's really easy to do that, right? Because you're in that same environment, that same look and feel, and can span that hybrid experience very cleanly as you make your journey to the cloud. So it's a really great benefit. There's a lot of change in the world, and if we can keep some things constant and give people a sense of familiarity, that's a really, really good thing. And we've seen a lot of really great feedback in the market on that.
Yeah, and I want to key in on that word familiarity. Oftentimes there might be some hesitation by an organization like, oh my gosh, we have to learn all these new cloud skills. We don't have a lot of cloud skill or any cloud skill. And FSx ONTAP really lowers that barrier. So an organization that's been using ONTAP on-prem can really parlay their experience to step into the cloud using their existing skill set. So using features like SnapMirror, SnapLock, for example, that's all very familiar and accessible to the operators on-prem, and being able to really bridge into the cloud and take advantage of the scalability and elasticity of the cloud.
So you mentioned scale as being one of the challenges earlier. Is there any limitation to scale with Amazon FSxN?
A couple of things to note. One is from using FSxN or FSx for ONTAP, there's actually two types of tiers of storage. One is the performance tier and one is the capacity tier. If we think about the performance tier, The capacity for that performance tier, which is SSD storage, is up to 192 terabytes. But like everything, we're always listening to customers in terms of their signals and their requirements. And we always try to respond to those customer signals and requirements. So you would definitely expect that over time, like, for example, the limit that I just mentioned today, which you can find on the FSx user guide information that's available on AWS, it's not 192, but it's likely that over time that those things will change. In terms of other types of capacity and scaling features, I highly recommend everybody actually checking out the documentation that's available under FSx for NetApp at AWS, and you can get all the specific statistics for the capacitor or the top end for throughput and how that actually scales for IOPS. All the speeds and feeds that you might be interested in is easily available at your fingertips. And again, as we listen to customers, you'll see changes over time.
Yeah, and these days, 192 terabytes is pretty good. In reality, 192 terabytes isn't necessarily 192 terabytes with modern storage vendors.
Right. I can point to a shared customer, eHealth New South Wales.
Mm-hmm.
So this is a great story as part of their strategic move into the cloud. They wanted to move their enterprise imaging workflow or environment into the cloud, and they did that with FSxN. And they initially started out with migrating about 1.2, 1.3 petabytes of images into AWS over FSxN. And now that data set continues to grow. So there is also the capacity tier, which from an imaging workload perspective, a petabyte of medical images is pretty significant. And FSxN is able to address that.
Yeah, I think what I was getting at was with a modern storage system like ONTAP, we have storage efficiency features that are built into the product, right? So I would imagine that Amazon FSxN can leverage things like deduplication or compression or even fabric pool tiering off to other lower cost S3 storage.
Yeah, exactly. You just mentioned fabric pools. That is a key component of FSxN, and that's actually the key piece of technology that's moving medical images, say, from the performance tier to the capacity tier for FSxN. And you're exactly right. There are capabilities to configure and set up FSxN, being able to take advantage of deduplication, compression, for example. And if you wanted to, you can actually model this out for yourself. You can go to the pricing calculator at AWS for the FSxN service, and you can specify the number of the actual capacity that you need, the types of throughput that you would need, and you can even apply how much deduplication that you might be able to take advantage of, and then have an idea of what that system configuration might look like.
Yeah, and in a medical imaging workload, you're not going to get a lot of savings from things like compression because those are images and they're already compressed. But
Right.
the nature of medical imaging data sets is that they tend to just kind of hang around and they don't get used all the time. So something like a fabric pool where cold data ages out and goes off and tears off into the happy cloud area, right? That's going to happen pretty frequently, I think, with this type of workload. Would you agree with that, Kim?
Yeah, absolutely. And we can help organizations, even with storage assessments, to look at their aging data that is on-prem today and figure out what capacities of data do you have with your medical images that hasn't been accessed in 2 or 3 years. Those would be good candidates to identify, isolate, and promote perhaps to a cloud instance. If an organization is just starting their cloud journey or just starting their journey with better data management for medical imaging, it's a great place to start and to look at that aging data. And there's some really interesting programs that we can help you get started very quickly and very cost efficiently with these types of storage assessments and give organizations just really good insight on what the art of the possible is towards better data management.
So you mentioned you have a performance tier and a capacity tier. What sort of use cases would a performance tier be good for in a medical imaging workload? I know you could use it potentially for all use cases, but sometimes you don't need that much performance. Where specifically would the performance come into play and be useful for medical imaging?
So all my medical images, when they're generated from the modality or file format images, and those are generally today how the current day medical imaging viewers process and read data for primary diagnosis. So file is very important and very highly performant file is very important for medical imaging workflows for primary diagnosis. So that's really why FSXN is such a great fit for this workload in particular.
Kim and I have been working with different imaging ISVs, and as they've gone through and they're qualifying and validating, is FSXN fit to be able to bring their solution into AWS, they're discovering that they can actually optimize the performance tier to really be able to target that capacity that's best fit for that particular customer. It can be a small customer that might be doing 40,000 studies a year to a customer that might be doing 1 million studies per year. And then at the same time, as part of their imaging application, it's storage aware. And so they can set up the right policies, then at the right time be migrating those images into the capacity tier of FSXN. And then when needed, they're brought back into the performance tier to be read at the appropriate time.
Right, and that's kind of what I was getting at. You don't want to store all your medical images on the performance tier because that's not necessary. It's kind of overkill, and that becomes very costly.
Right.
So there is this consideration there, and I was just curious if there were use cases where the performance tier was genuinely beneficial, and it sounds like it's on the creation of the images themselves.
It's on the initial primary diagnostic interpretation of the images, yes.
Oh, so the reading of the initial images.
Yes, yes.
Okay.
That really time-sensitive part of being able to deliver patient care in the quickest manner possible.
Gotcha. All right, cool. So, there are other ONTAP feature sets that can help out here. Things like flex group volumes, flex cache volumes. Are you seeing customers asking about these things, leveraging these things, or are they just future-looking things?
Actually, there are some ongoing examples where customers are really curious about how they can take advantage of a flex cache, and there is experimentation going on because in some cases, depending upon where you're operating, latency becomes crucial in terms of being able to request or read back images, even to be able to write and get the images into a file system. And so there are customers today with workloads where they are experimenting either reading through or writing through a flex cache, their images, and then eventually those images move on through to an FSX file system. And what's pretty cool, and in fact, there's a couple of blogs out there that really highlight the different ways that you can take advantage of flex cache along with FSXN to satisfy different ways that images could be accessed in a given region.
Yeah, I always feel like that's one of those features that really fits into this type of use case nicely, because when you're dealing with medical imaging, you're often dealing with a lot of remote sites, whether it's a doctor's office out in another state or another city where your data set maybe resides somewhere else. Having that locality is really going to add extra benefit to accessing those files when you need them and make sure it's done quickly and efficiently.
And just to come back to where we were at the top of the podcast is we're beginning to see customers with these new and emerging workloads like digital pathology, where they see potential in terms of as they scan images, writing those images directly to a flex cache, and then being able to forward on those net new captured images to a FSXN file system in AWS, which then kicks off a whole digital pathology workflow. So, like I said, a lot of experimentation going on.
All right, so one aspect of medical imaging that is coming up more and more these days is the AI ML aspect of it, using machine learning to actually take these images and try to learn something from them, right? So where does that fit in to the Amazon FSXN story? Does AI ML have a place with this type of workload?
Yeah, certainly a lot of different groups. They work a lot of different ways and use a lot of different AI ML applications. A lot of them expect to work with file. If your images are already in FSXN, and especially at the performance tier, can definitely be configured and tuned to be able to serve those images out. I imagine like a batch EC2 compute environment that's doing some sort of training where you don't want storage to be the bottleneck. FSXN can definitely play a role being able to serve images to train models and train them more quickly. So it's a definite option for customers to pursue that path.
All right, sounds like medical imaging is a great fit for Amazon FSXN. So again, if we wanted to reach you or find more information, Sasha, how do we do that?
Probably the best way is look me up at LinkedIn. I'm out there, and just message me through there. Or if you happen to be a healthcare provider customer that's working with AWS, please just start out with your account team that you're working with today, and they'll be able to navigate internally here how to get in touch with me, and we can dive deeper on your use case.
And do we have any information we can point people to in our blog?
Yeah. So first off, one of the things I really want to highlight, because we highlighted things like operational agility and efficiency and some of the innovation. There is a report out there commissioned by AWS and NetApp. It's a Forrester report, the total economic impact of Amazon FSx for NetApp ONTAP. I highly encourage everybody to go check it out. The link will be in the description for the podcast, or you can just go directly right now to netapp.com and check it out. There's a lot of great actual hard numbers in terms of the economic impact, along with highlighting some of the intangible benefits that healthcare customers, as well as other customers in other industries, have been realizing with FSxN.
All right. And Kim, how do we reach you?
Yes, you can reach me at kim.garriott@netapp.com or on LinkedIn, and happy to talk to you about your medical imaging data strategy anytime.
All right, awesome. Well, thanks so much, Kim and Sasha, for joining us today and talking to us all about medical imaging on Amazon FSxN.
All right, that music tells me it's time to go. If you'd like to get in touch with us, send us an email to podcast@netapp.com or send us a tweet @netapp. As always, if you'd like to subscribe, find us on iTunes, Spotify, Google Play, iHeartRadio, SoundCloud, Stitcher, or via TechOnTapPodcast.com. If you like the show today, leave us a review. On behalf of the entire Tech on Tap podcast team, I'd like to thank Sasha Pagel and Kim Garriott for joining us today. As always, thanks for listening.
Oh, yeah. Is it just me that's getting off on this? Oh, yeah.